नोट्स कंप्लीट केल्या का सगळ्यांनी? क्या माझ्या बरोबरच नोट्स लिहा. एक काम करा, नोटबुक काढा, माझ्या बरोबरच नोट्स लिहा. हाँ 22 काय 22 या नोट्स अपलोड केल्या नव्हत्या? बरं, कुठेपर्यंत अपलोड केल्या होत्या बघा? इथेपर्यंत होता? बरं, 2 पेजेस सोडा, 2 पेजेस. हाँ suppose we have uniform electric field like this. In a uniform electric field, if I want to find potential difference between the 2 points, then I know the general formula is potential difference between the 2 points is equal to minus in the bracket integral of E bar dot dr bar. This is the general formula to find out the potential difference. Now I can say that because this electric field is constant, I can take it outside integration. So inside integration I will have this dot dr bar or E bar dot integral dr bar. So simply what I get is E bar dot integral dr bar. Let me write it as dr is a small displacement, so integral dr will be the total displacement. So this can be used only if electric field is uniform. This can be done only for uniform electric field. This formula is applicable only if electric field is uniform. Only if electric field is uniform. You can interpret this formula as magnitude of electric field into magnitude of displacement into cos of angle between them, or you can interpret this as minus E bar dot delta r perpendicular. Minus magnitude of electric field into the perpendicular distance between the two equipotential surfaces. So from that you can get magnitude of electric field as minus delta V upon delta r perpendicular. Of course this is a vector relation. write down once again. The potential difference can be generally written as minus integral of E bar dot dr bar. But if this electric field is uniform, then you can write delta V is equal to minus E bar dot integral dr bar, which is equal to minus E bar dot delta R bar. This dot product can be further solved as magnitude of electric field into magnitude of displacement into cos of angle between them, and this can be written as perpendicular distance between the two equipotential surfaces whose potential difference you want to find out. And further you can write electric field E as minus delta V upon delta R perpendicular. If you just think of numbers, then you shall say magnitude of electric field is equal to potential difference upon perpendicular distance. This is applicable only for uniform electric field. The formula potential difference upon distance is applicable only for uniform electric field, not in all cases. It is applicable only for uniform electric field, magnitude of uniform electric field. Generally we find electric field as minus in the bracket dou V by dou X plus dou V by dou Y plus dou V by dou Z. You have to find electric field at each point, because generally electric field can be different at different points, but if it is same at all points, then you can directly find out the answer as potential difference upon distance. For these formulae, the potential difference means potential at final point minus potential at initial point. So let's say this is the point, final point. Let's say you can choose any point on this surface as final point and any point on this surface as initial point. All the points on this surface will have potential V1. All the points on this surface will have potential V2. Let us say the separation between them is small r, or let's say R1. Then magnitude of electric field can be written as potential difference upon distance. Because you are finding the answer numerically, here you will not write final minus initial or initial minus final. Here you will simply write higher minus lower. Now which is higher potential? V1. And which is lower potential? V2. So here to find the magnitude directly you can write V1 minus V2 upon perpendicular distance between the two equipotential surfaces. Don't take any general distance. Take perpendicular distance between the equipotential surfaces, which is R1 in this case. Or suppose any point on this surface has potential V3, any point on this surface has potential V1, and perpendicular distance between these two surfaces is, let us say, R2. Then also you can write potential difference upon distance. Here, because you are finding the answer numerically, you will not say final minus initial. Here you will say higher minus lower. You are just finding magnitude of electric field. So higher is V2, lower is V3 upon perpendicular distance between the two equipotential surfaces. What is that? R2. The distance is R2. This can be used only if electric field is uniform. Potential difference upon distance, direct formula can be used only if electric field is same at all points. If it is different at different points, then at each point you will have electric field different, then you cannot use this formula. You have to take partial derivative. You cannot use this direct formula. Okay. Similarly, what if you have this kind of electric field? This electric field changes with the radial distance r. What is the magnitude of electric field E here? K 2 lambda upon r. Let us say the rod is positively charged. If it is positively charged, electric field will be away. If it is positively charged, electric field will be away. If it is negatively charged, electric field will be towards. Now I want to find potential difference between these two surfaces. Here you cannot use the formula potential difference upon distance. The reason is electric field is not same at all the distances. It is different at different distances. So what is this distance? R1. What is this distance? R2. Now how will I find the potential difference between these two surfaces? The reason is again simple. The potential difference, general formula is what? Minus integral E bar dot dr bar. This is the general formula. Now you can write this as magnitude of electric field into magnitude of displacement, small displacement, into cos of angle between them. Now while moving from point 1 to point 2 on this path, at any general point, electric field is away, rightward, and displacement is also rightward. So what we can do is, we can write magnitude of electric field as K 2 lambda upon r, then magnitude of displacement dr, both of them are rightward, so cos of angle between them can be written as 0. So cos 0 is no need to write. This minus as it is, K 2 lambda outside integration. Inside integration we have dr upon r. Let's say initially we are at position r1 and finally we are at position r2. So this minus K 2 lambda, this dr upon r, integration will be ln r, and the limits will be from r1 to r2. So this is the formula for potential difference between the 2 points on 2 surfaces. So here we will get the formula for potential difference as, final conclusion is, potential difference delta V is equal to minus K 2 lambda ln log of upper limit minus lower limit will be log of upper limit upon lower limit. This is the formula for potential difference between these 2 points if you have the line charge. And what is the formula for field? It is K 2 lambda upon r. So you just write down these two formulae for electric field and potential difference. Don't write the derivation. Forget about this derivation. You just write down the formula for potential difference and the electric field. Write down. Again here, this delta V means final point potential minus initial point potential. Final point potential minus initial point potential. बोलता लिहा, आवाज नको आहे कोणाचा. You can just write down this heading and this formula. डायग्राम नंतर तुम्ही घरी जाऊन नोट्स मध्ये कंप्लीट करा. राहिला असेल नंतर नोट बघून कंप्लीट करा. पुढे सगळं. Let us solve the examples. बोलणं नको आहे तुमचं मध्ये मध्ये. Write down. Example number 30. In the following figure, along which path the work done will be maximum in carrying a charge from point A to point B in the presence of another charge? चलो बघ रे. वर तू. वर. वर तू. वर की पटकन. का झोपलायस? हां? इकडे इथं वर. ठेवते पुस्तक इथं. वर. Write down. Along which path the work done will be maximum. Along which path the work done will be maximum in carrying a charge or while carrying a charge. In the presence of another charge. Okay, so let us say this is our charge small q, which is to be taken from point A to point B. So it can be taken from point A to point B along different paths. Let us say this is the first path, straight line path. This is the second path. This is the third path. This one is third, and let us say this is the fourth path. This one is, let us say, is the fourth path. We have to check along which path the work done in carrying this charge q from point A to B is maximum. Now this is to be done in the presence of some another charge. So you can take this another charge as source charge. This is our source charge. this source charge will produce in this region its own electric field. So you can call this as region of electric field. You can call this as region of electric field. You can call this as region of electric field. In this region of electric field, who will produce the electric field? The source charge will produce the electric field. And we have to move this test charge from point A to point B. So there is already a force acting on this test charge because of the source charge. And now you will apply equal and opposite force and you will move it from point A to point B. Now we know the fact that electric field is conservative field, or electric force is conservative force. Electric field is conservative field, or electric force is conservative force. Therefore, work done by electric field or against the electric field work done by electric field or against the electric field is path dependent or independent? Independent. Correct. It is path independent. Electric field is conservative field. Therefore, work done by the electric field or against the electric field. Against the electric field means by the external agent. And by the electric field means by the electric force. Is path independent. Therefore, work done along path 1 is equal to work done along path 2 is equal to work done along path 3 is equal to work done along path 4. So all of the works will be same. In carrying the charge Q from point A to point B, all the works you are going to obtain as same numbers. Now let us try to prove this mathematically. We know work done by the external force on a system, our system is this small q, is change in its Ke plus change in its Pe. Now let us say we do the work without accelerating the small q, then obviously change in its kinetic energy will be 0. So work done by the external agent will be exactly equal to change in its potential energy, means final potential energy minus initial. So finally it is at point B, so potential energy when it is at B minus potential energy when it is at A. Now we know the formula for potential at a given point. What is formula for potential at a given point? Potential energy of the test charge upon the test charge. Then what is the formula for potential energy? It is potential into charge. So what is your potential? What is your potential energy at point B? Potential at B into your charge minus what is your potential energy at A? Potential at A into your charge. So clearly it is VB minus VA into Q. Clearly it is potential difference into charge. So what matters is potential difference, that is potential at final point minus potential at initial point. What matters is potential at final point minus potential at initial point. In between points or potential at in between points doesn't matter. Potential at in between point doesn't matter. हाँ. So what matters is potential difference into charge. Who will decide the potential at point B? Not the test charge. Who will decide the potential at point B? The source charge. Who will decide the potential at point A? Source charge. So path doesn't matter. In this formula, actual path doesn't matter. What matters is potential at final point minus potential at initial point, which are already predefined. You go by any path. Your path will not decide final potential and initial potential. Final point potential and initial point potential are already predefined by the source charge. So this is how mathematically also you can prove that the work done is path independent. This is how mathematically you can prove that work done is path independent. Next question number 14. Write down with me. Question number 14. A 20 microcoulomb charge is situated at the origin of the xy plane. So draw the coordinate system and put 20 microcoulomb charge at the origin of the coordinate system. The value of Q is equal to 20 microcoulomb. What will be the potential difference between the points 5a, 0 and minus 3a, 4a? So this is point A. Potential at that point, coordinates of that point A are 5a, 0 and B has minus 3a, 4a, and we have to find potential difference between these 2 points. So let us call it as VB minus VA equal to question mark. So let us plot the point A. Let us say this is the point A, 5a, 0, and where will be the point B? In the 4th quadrant, in the 2nd quadrant, minus 3a, 4a. So minus 3a, 4a, somewhere here. This is your point B. Its coordinates are minus 3a, 4a. Minus 3a, 4a. Okay, this is our source charge. This source charge will decide some potential at point A. The same source charge will decide some potential at point B. And you have to find potential at B minus potential at A. Our source charge is a point charge. So because of point charge, what is the potential at given distance r? What is the formula for potential due to point charge? kq upon small r. If they ask you field, it will be kq by r square, and if you are asked potential, it is kq by r. So let us find potential at B as kq upon r. Let us call this distance of point B as RB. Let us take this distance as RB. So potential at point B will be kq by RB. Similarly, at point A, what is potential at point A? It will be, our charge is small q, not capital Q. Potential at A is kq upon RA. kq upon RB minus kq upon RA. Now k is known, q is known. This distance of point B and distance of point A, these are the problems. So find distance of point B or distance of point A. Distance of point A is easy to find. What is distance of point A? What is distance of point A? 5a. You can directly get the distance of point A as 5a. And what about distance of point B from the charge Q? What is the distance of point B? Point B is a distance as It will be again 5a. You can use Pythagoras theorem. This is 3a, this is 4a. So under root minus 3a square plus 4a square, that will be 25a square, that will be 5a. You can call this set of equations as 2. Use equation 2 in equation 1. What will be the potential difference between these 2 points? It will be kq upon 5a minus kq upon 5a, 0 volt. Between these 2 points, you will have 0 potential difference. Between these 2 points, between these 2 points, you will have 0 potential difference. Now this was mathematical answer. What will be your logical justification for this? What will be your logical justification for this? How or why potential at A and B are equal? Because they are on equipotential surface. The answer is because they are on equipotential surface. We know because of point charge, shape of equipotential surface is sphere. Yes or no? They are on same surface. They are not on two different spheres. They are on same spheres. You can take this point C also. Potential at C will also be equal to B, will also be equal to A. You can take this point D also. Its potential will also be same as B, same as C, same as A, because all of them are on same surface. Because of point charge, what is the shape of equipotential surface? Spherical. Because of line charge, cylindrical. And because of uniform electric field, they are planes. Because these points are on same equipotential surface, because these points are on same equipotential surface, therefore their potentials are same. This is logical justification. Next question number 15. Solve with me. Electric potential for a point x, y, z is given by electric potential at location x, y, z is given to you. It is 4x square volt. Okay, it changes only with the x coordinate. Means it is one dimensional case. Electric field have only x component, not y and z. Find the electric field at point 1, 0, 2. We have to find electric field at point 1, 0, 2. Let us use the general formula of electric field. Minus in the bracket dou V by dou x into I plus dou V by dou y into z plus dou v by dou z into k. Call this as equation 1. Now these three partial derivatives are unknown. You can directly use the formula minus dv by dx. Here v changes only with respect to x, so other derivatives are going to be 0. But let us do all these steps. Let us find dou v by dou x. Dou by dou x of v. What is v? 4x square. 4 outside derivative. X square derivative with respect to x. 2x. So answer shall be 8x. Answer is 8x. Similarly find dou v by dou y. It will be dou by dou y of v. What is v? It is 4x square. Now 4 is also constant. and x is also constant because derivative is with respect to y. X will be taken as constant, so its derivative will be 0. 4x square will be taken as a constant. Similarly, dou by dou z of 4x square. Again 4 is constant, x is taken as constant because of partial derivative with respect to z. So constant derivative is 0. You can treat these equations as set of equation 2. You can use equation 2 in equation 1 and you can get electric field. E bar is equal to minus in the bracket dou v by dou x is 8x into I, dou v by dou I is 0 into z, dou v by dou z is 0 into k. So answer of electric field is minus 8x into I cap. This is the electric field at any general point x comma y comma z. Comment on this. This is uniform or non-uniform? Non-uniform, it changes with the x. So it is non-uniform. Now you on your own find particular electric field at particular position. Put x is 1, y 0 and z 2. Put x equal to 1. So you will get the answer as minus 8 I cap. What will be magnitude? 8 volt per meter. And direction minus I means negative x. Comment on this field whether it is uniform or non-uniform. Question is wrong because it is at particular point. See field at general point, then comment on it as uniform, non-uniform. At particular point, just by looking at field, you cannot comment whether it is uniform or non-uniform. You have to check electric field at all points. Only then you can say uniform, non-uniform. Anyone has any doubt in this question? काय करतोय कळते का? लपून का बसलायस? नोटबुक आणि इकडे नोटबुक दे. लायस का बघू? तुझी नोटबुक दे रे समोर. दे लवकर. हां? ये बाहेर आहे. सगळेजण दिसले पाहिजे तर मला लपून कोणी बसायचं नाही कोणाच्या मागे. का नाही लिहिलास? लिहित का नाहीयेस? ये इकडे समोर. वर हात तुटलाय. बघतोय डोकं दुखतंय. आजारी आहेस? मग काय करा? बाकीचे लिहित आहेत. बराच वेळा ऑब्झर्व करतोय मी. बघत नाही आहेस माझ्याकडे तू म्हणजे लिहित नाही आहेस. बघा आता मला सगळे दिसत आहेत. कंटिन्युअसली दिसत आहेत. तुमचं लक्ष पूर्ण वेळ माझ्याकडे पाहिजे. मी ऑब्झर्व करतोय. जे एकमेकांच्या मागे लपतात त्यांना मी स्पॉट आउट करणार पहिल्यांदा. बघा लेक्चरच्या वेळी आपण सिरियसली अभ्यास करूया, नंतर दंगा मस्ती भरपूर करू. लिहून झालंय सगळ्यांचं? पुढं राईट डाऊन क्वेश्चन नंबर 16. Potential in the xy plane is given as V is equal to, write down, 5 in the bracket x square plus xy, these many volts or volt. Find electric field at point, 1 comma -2. Again you can write E bar is equal to minus in the bracket dou V by dou x into I plus dou V by dou I into Z plus dou V by dou Z into K. You can call this as equation 1. What are the problems in this equation? These three partial derivatives. So find these three partial derivatives. Dou V by dou x means dou by dou x of V. What is V? 5 in the bracket x square plus xy, bracket complete, 5 constant, outside derivative, x square derivative with respect to x, 2x, xy derivative. While finding derivative of xy, y is constant, so it is outside derivative. X derivative with respect to x will be 1. X derivative with respect to x will be 1. You can multiply 5 inside, you will get it as 10x plus 5y. Similarly find derivative, partial derivative with respect to y, dou by dou y of v. V is what? 5 in the bracket x square plus xy. 5 is constant, outside derivative, x square derivative with respect to y. What is x square derivative with respect to y? 0 plus xy derivative with respect to y. Now xy derivative with respect to y means x will be taken as constant, so outside derivative, and y derivative with respect to y will be 1. So use the brackets carefully. So answer is simply 5x, and finally you have this dou v by dou z, that will be dou by dou z of v. What is v? 5 in the bracket x square plus xy, 5 constant, outside derivative, x square derivative with respect to z 0, and xy derivative with respect to z, that would also be 0. You can call these set of equations as 2. Now you can use equation 2 in equation 1. You can use equation 2 in equation 1. And you can write E bar is equal to minus in the bracket, again bracket, what is dou v by dou x? It is 10x plus 5y, bracket complete, into I cap. This is dou v by dou x plus dou v by dou y. It is 5x into z cap plus dou v by dou z. It is 0 into k cap. So it is this electric field. Now you want electric field at particular point. What is that particular point? 1 comma minus 2. So put x as 1 and y as minus 2. Use the brackets very carefully. 10 into x x is 1, y is minus 2 into I cap. Again 5 into x is 1, x ला 1 टाका, y ला minus 2 टाका. सगळे ब्रॅकेट्स अगदी केअरफुली बघा. So minus in curly bracket in square bracket 10 minus 10 0 into I plus 5 into z. So it is minus 5z. Magnitude is 5 volt per meter and direction negative y. This is electric field at that particular point, 1 comma minus 2 ला. Any doubt in this question? This was similar to previous question. Solve with me. Next example 70. चलेगा? करायला असेल नंतर नोट्स अपलोड करतो, त्यातनं कंप्लीट करा. लिहा माझ्यावर. The graph shows a variation of potential versus distance. Calculate electric field at various points. Calculate electric field at various points. वही यूनी पहले बेंचर में बस. Calculate electric field at various points. So we are given variation of electric field as a function of position. Here position is not x or y or z, it is r. So again it is one dimensional case. Variation of potential is given to you. Initially potential goes on increasing, then potential remains constant, and then it again goes on decreasing. Here position is 0, here position is 2, here it is 4, here it is 6. Position is measured in meter, potential is measured in volt. Here potential is 2 volt. This is point A, this is point B. Coordinates of A and B are given to you. This is point C. We have to find electric field at various points. Potential, how the potential varies is not given as mathematical function, it is given as graph. In the previous problem, potential was given as function of xyz, but here it is plotted directly. So potential can be either given as mathematical function or can be directly plotted as a graph. In both the cases we will be able to find out the electric field. Solution. We know electric field for three-dimensional case it will be what? Minus dou v by dou x into I, dou v by dou I into z, dou v by dou z into k. But if it is one-dimensional, you can simply write dv by dx into I. But here the dimension is not x. Here the dimension is not x. It is r. It is one-dimensional case, but it is not x. It is r. Not numerically, because it is one-dimensional case. Instead of considering e bar as vector, let us consider e as a vector. And let us ignore this I cap. If this e comes out to be negative, we will say that it is leftward field. And if this e comes out to be positive, we will say that it is rightward field. This is not the magnitude relation. This is still the vector relation. Because it is one-dimensional case, we are ignoring this bar and this bar and I. If the answer of electric field comes out to be positive, it is rightward field, and if it comes out to be negative, it is leftward field. But what is the geometrical meaning of derivative? dv by dr is similar to dy by dx, means it is what? Slope. So electric field is basically negative of slope. Slope of which graph? Potential versus position graph, or potential versus distance graph. Slope of potential versus distance graph is the electric field. Now, for all points from position equal to 0 to 2, slope is going to be same. Because it is straight line, no need to find slope at all points separately. At all the points you have same slope. Yes or no? For straight line, slope at all the points is same. So no need to find each slope separately. So what can be done is this. Write down. For r equal to 0 to 2 meter, write with me. For all these positions, what will be the electric field? It is negative of slope. For straight line, no need to find slope at each point separately. For straight line, you can directly find the slope as total change in y upon total change in x. No need to say dy by dx. You can directly find delta y by delta x. If it is a straight line, no need to find slope at each point separately. At all points, the slope is actually going to be same. And that value you can find directly by total change in y and total change in x. So you can write total change in y means delta v, total change in x means delta r. So minus in the bracket change in potential, total change in potential, total change in y किती झाला बघा 0 to 2 साठी means 0 to a. Total change in y means final y minus initial y. Final potential minus initial potential. Final potential is how much? 2. Initial potential 0. Similarly, upon change in x, final x minus initial x. So answer is minus 1. Minus 1 चं meaning काय असते? 1 volt per meter leftward. This electric field is 1 in magnitude, but it is leftward. That is the meaning of minus 1. So at any point between 0 to 2, your electric field will be 1 volt per meter. For all these points, electric field will be 1 volt per meter and leftward. Now, for position equal to 2 meter to 4 meter, for all these positions, what will be the electric field? Again, it is straight line. So no need to find slope at each point separately. Slope at all the points is going to be same. So it is negative of slope. Means negative of, no need to say dv by dr. You can directly say delta V by delta R, which is equal to minus in the bracket. What is change in potential from A to B? Final potential is 2. Initial potential at A is also 2. Upon distance, final position is 4. Initial is 2. Change in y upon change in x. The answer is 0. You could have directly written answer 0. It is a horizontal line. Its slope is going to be 0. You could have written the answer directly. For horizontal line, slope is going to be 0. Similarly, for positions equal to 4 meter to 6 meter, for all these positions, again it is a straight line. No need to find slope at each point separately. You can find the slopes directly. It is negative of slope, means negative of what? Delta V by delta R. Negative in the bracket, Negative in the bracket. Total change in potential means final potential minus initial potential. For B to C, what is final potential? 0 minus initial potential at B, 2, upon distance, final position B to C means final position is 6, initial position is 4, change in y upon change in x. So answer is minus of minus 1. So it is plus 1. What is the meaning of plus 1? Magnitude 1 volt per meter, and plus means field is rightward. The electric field is directed rightward. For B to C, slope is negative. B to C, slope is negative, and minus slope is positive. Yes, field positive का आली का B to C चा slope काय है? Negative. So minus slope will be positive. Now you know electric field at all the points. Now try to plot electric field as a function of position. Try to plot electric field as a function of position. So let's say this is electric field, both in magnitude and direction, and this is position. For 0 to 2, what is the electric field? It is 1 but leftward, means minus 1. So minus 1 field का shift out करना. For 2 to 4, what is the value of electric field for positions 2 to 4? It is 0. And what is the value of electric field for positions 4 to 6? Plus 1. Means rightward. Rightward field is plotted positive. So draw the graph like this. So in the exam, you will be given the graph of potential, and you will be asked graph of field. Potential graph will be given to you, and field graph will be asked to you. Potential graph will be given to you, and field graph will be asked to you. So today we have completed all the problems based on field and potential relation. From last 2 days we are solving the questions, or we are dealing with field and potential combined. Simultaneously field आणि potential बरोबर आपण डील करतोय. त्याच्यावरती क्वेश्चन्स कसे असतील? You will be given potential, field will be asked. Use partial derivatives. You might be given field, potential difference might be asked. Use 3 different integrals. You might be given graph of potential, might be asked graph of field. So for the point 0 to 2, field is uniform but leftward. 0 to 2 also it is 0. Means 0 can be taken as uniform also, no problem. For 4 to 6, field is again 1 everywhere but rightward. So this is uniform field. For 4 to 6 region, this is uniform field because it is same at all points. For 0 to 2, this is a uniform field. It is 1 but leftward. सगळे पॉइंट समजले का बघा आजचे? सीबीएसई वाल्यांनी होमवर्क चेक करून घेतला का? कोण जर राहिला असेल, आज लास्ट डे असेल होमवर्क चेकिंगचा. आज पेपर आहे ना, उद्या आहे का? ठीक आहे, आज ही काय होमवर्क घ्यायला नको. नोट्स सगळ्या अप टू डेट फक्त करा. या सगळ्या नोट्स मी आज 6 वाजेपर्यंत संध्याकाळी अपलोड करतोय. काय व्हिडिओ लेक्चर मिस झालेले असतील, टेस्टमुळे काही लोक अब्सेंट असतील, त्यांनी व्हिडिओ बघून सगळ्या नोट्स कंप्लीट करायच्या आहेत. हे सगळे एका लिंक वरती अपलोड केलेलं आहे. लिंक वरती एक्स्ट्रा क्वेश्चन्स पण दिलेत, मल्टी चॉईस आणि ॲडव्हान्सचे PYQs. डाउनलोड केले का? कोणी कोणी डाउनलोड केले? उद्यापासून आपल्याला ते टास्क घ्यायचा आहे. काय काय टास्क असणार आहे आपला आता डेली? सॉल्व्ड एक्झाम्पल्स, क्वेश्चन सेट, JEE PYQ, HCV आणि एक्स्ट्रा क्वेश्चन्स. ज्या दिवशी जे सांगेल त्या दिवशी ते करायचं आहे. हे सगळं करत असताना चॅप्टर संपलं की 2 दिवस आपल्याला स्टेट बोर्डचा होमवर्क आणि CBSEचा होमवर्क पण करायचा आहे. सगळ्या गोष्टी लक्षात ठेवा. सगळं मॅनेज करायचं आहे. थोडं त्रास होणार आहे पण करूया. तर जन्माला आलोयच, काहीतरी करूया. करूया ना? हां, ठीक आहे. घ्या ब्रेक.